Where is question 7?
Ma'am, in this page.
Okay. The question is missing here in this. Okay, we were doing from the book.
Yes, ma'am.
Okay, so have you done that? Reduce the following fractions to simplest form. That's question number 7.
Yes, ma'am, done.
Okay, good. So let's discuss what is the simplest form of this 48 by 60.
Ma'am, 4 by 5.
4 by 5. Okay. Let me take a black pen. Okay, that's 4 by 5. Okay, what is the simplest form of this? 150 by 60.
5 by 2.
Very good. 84 by 98.
6 by 7.
Very nice. 12 by 52.
2 by 9.
2 by 5.
Ma'am, 9. 2 by 9.
2 by 9. No. With which number you divided them? It won't be 2 by 9. Even if it is 2, you will get when you are dividing this by 6. Is it?
Yes, ma'am.
54 will not, 52 will not go with 6, no?
Oh.
So, if you divide this by 4, okay,
Yes, ma'am.
you will get 4 3s is 12, and this one you will get as 13. Okay,
Yes, ma'am.
so that's 3 by 13. Okay,
Yes, ma'am.
you have the next, what did you get for 7 by 28?
1 by 4.
1 by 4. Good. Okay. Let's take some more questions. Okay, let's do question number 8 from the book only we are taking. Question number 8. Ramesh had 20 pencils. You have the book with you, no?
Yes, ma'am.
Okay, so I'm reading the question from the book because the question is not printed here.
Okay.
This is question number 9. Okay, Ramesh had 20 pencils. Okay, I'm just writing whatever's in the statement we are given. Ramesh had 20 pencils. This is for Ramesh. Sheelu had 50 pencils. Okay, Jamal had 80 pencils. After 4 months, Ramesh used up 10 pencils. Okay, after 4 months now, Ramesh used up 4 pencils, so that means 16 are left with Ramesh. Sheelu
Yes,
used up 25 pencils. Okay, that means Sheelu used up 25 pencils. Okay, that means out of 50, she used 25 she is left with. Okay, Jamal used 40 pencils. So he had 80 pencils altogether. Out of that, he used 40. So he is left with 40. Okay. What fractions did each use up? Check if each has used up an equal fraction of his or her pencils. Now we have to find what fraction of pencils have they used. So initially they had these pencils. Ramesh had 20, Sheelu had 15, Jamal had 80. So what was the fraction of pencils with Ramesh? What is 16 pencils he used, and 20 pencils were the total number of pencils. So the fraction is 16 by 20.
Yes, ma'am.
Yes, 16 or 10? 10. It's not 16.
Oh.
After 4 months, Ramesh used up 10 pencils, not 16, it's 10. So fraction is 10 by 20. Okay, so that means it's 1 by 2. Okay, now next part is that Sheelu had 50 pencils and she used up 25. So that means the fraction will be 25 used up and 50 were the total. So this is a fraction.
Yes.
So that is again 1 by 2. 25 by 50 is 1 by 2.
Yes, ma'am.
Now Jamal had 80 pencils in total and he used up 40 out of those. So that means the fraction is again now 1 by 2. So the fraction is equal here.
Yes,
Okay.
ma'am.
In the question it's asked, no? Check if each has used up an equal fraction of their pencils. So the fraction is equal. So both have used equal fraction of their pencils. Got it?
Yes, ma'am.
So you can write down in your notebook with the statement, because this is a statement question. You need to give answer in a statement only. Okay. You can write here Ramesh had 20 pencils, Shilu had 50 pencils, Jamal had 80 pencils. Okay.
Ma'am, I'm not allowed to write in my textbook till the lesson is going on in my class.
What are you saying?
Ma'am, I can't write the answers in my textbook because
No, I'm not telling you to write in the textbook, but whatever notebook you have, you can write down there. Fraction of pencils used by Ramesh, it's 1 by 10 by 20 equals to 1 by 2. Fraction of, I'll write for you here. You can write down like this. Answer, please. Okay. Fraction of pencils used by Ramesh. Okay. Is equal to 10 by 2, 20, which is equal to 1 by 2. Then same statement, fraction of pencils used by Sheely, which is 25 by 50, which is again equal to 1 by 2. Again, same statement, fraction of pencils used by Jamal. That's 40 by 80, which is equal to 1 by 2. So, this implies, we can write this with arrow, this implies that all of them use equal fraction. All of them used equal fraction of pencils. All of them used equal fraction of pencils. Okay. Just a second, I'm coming. Okay. Okay, let's see the next question. This is match the equivalent fractions and write two more fractions for each. So can you do this matching question for homework, Neha?
yes, ma'am.
This is just to match the fraction with its equivalent.
Yes, ma'am.
Question number 9 for homework. Okay, let's take some more questions. Okay, I'm taking some extra questions based on this, on equivalent fractions now, before we move to the next part. Have you seen your Sunday test, Neha?
Yes, ma'am.
You've seen, no?
Ma'am, actually you said we'll revise elementary shapes like for the objective test.
I've given you elementary shapes. Do you have any doubts in that? Otherwise, tomorrow you don't have a class, no?
No, ma'am.
Okay. So we must revise something from elementary shapes. Okay?
Okay, ma'am.
Let's revise something from elementary shapes then. Okay, I'm coming to elementary shapes. This. Let's revise this chapter, okay? You have now last 10-15 minutes to revise it. Okay, so in elementary shapes, Neha, we first did, how can we take them accurate measurement? If we take, how is it advisable to take the accurate measurement? By using a scale or by using a divider? So that's by using a
Divided.
divider, okay? Then we had questions like this. If A, B, C are 3 points on a line such that AB is equal to 5 centimeter, BC is 3, AC is 8 centimeter, which one of them lies between the other two? Okay. So we were doing questions like this. A, B, C are 3 points on a line. AB is given 5, BC is 3. So that means the total distance of the line is 5 plus AB plus BC. Like
Yes.
this. From A to B, this is 5 centimeters. From B to C, it is 3 centimeters. So that means the total length of AC is 8 centimeters. So which of them lies between the other two? That's obviously
B.
B. Okay. Okay. Verify whether D is the midpoint of AG. So we just have to see if D is the midpoint. That means equal portions are there on each side. This side also I can see 1, 2, and 3 parts here. This side also the same distances here, 3 centimeter and 3 centimeter. So D is the midpoint. Okay. So in this chapter we studied about angles, right angle, straight angle. Right angle is 90-degree angle. Okay.
Yes, ma'am.
And acute angle is angle which is less than 90 degrees. Yes,
Yes.
please.
Yes, ma'am.
Is less than 90 degree is acute angle. Angle greater than 90 degree and less than 180, which lies between 90 and 180 degrees, is called
Obtuse angle.
obtuse angle. Very good. And angle which is greater than 180 and less than 360. What angle is that called?
Reflex angle.
Reflex angle. Very nice. Okay. And complete angle is how much?
360 degrees.
360 degrees. Very good. Okay, and we saw some questions like this. What fraction of a clockwise revolution does the R hand of a clock turn through when it goes from, let's say, 4 to 7? If the clock needle is at 4, from 4 to 7, if it has to move clockwise direction, that
Yes.
means how many clockwise revolution will it take?
Ma'am, 1/4.
1/4 of the revolution, is it?
Yes, ma'am.
That means it's taking 15 minutes, 3 hours like that. Okay. 4
Yes.
to 5, 5 to 6, and 6 to 7. Okay. 1/4 of the revolution. Where will the R hand of a clock stop if I'm taking the second one? If it starts at B, if it starts at 2 and make half of a revolution clockwise, where will the hand of a clock will stop if it is taking half revolution starting from 2?
Ma'am, 8.
8. Very good. Okay. Okay. Which direction will you face if you start facing east? Okay. Say Neha, if you are facing east and make half of a revolution clockwise,
Ma'am, west.
west. Half revolution means exactly opposite of that direction.
Yes.
So you know the directions. This is north, and below exactly opposite to north is south, and towards the right side of the north is east, and towards the left side of north is west.
Yes.
Okay, like this. Okay, find the number of right angles turned through by the, I'm taking this question number 5. Find the number of right angles turned through by the hour hand of a clock when it goes from 10 to 1. Let's take this. Number of right angles that the clock will turn through to go from 10 to 1. How many right angles will it move? From 10 to 1. 10 to 1 means 10 to 11, 11 to 12, 11, 12 to 1. So that means one right angle, Neha?
Yes, ma'am.
Any confusions? Yes,
Ma'am,
Neha?
does the minute and also count?
So you can always make a clock in front of you like that. Okay?
Okay, ma'am.
So even if you are giving your test or something in one corner of your notebook, you can just make a small rough figure.
Okay, ma'am.
So from 10 to 1 means this is one right angle. 15, it's taking gap of 15, no? 5 minutes gap, 5 minutes gap, 5 minutes. Either you call it 5 minutes or you call it 1 hour gap, 11 to 12, 12 to 1. Okay, so that's quarter of a revolution. So that's one right angle. Okay, how many right angles do you make if you start facing west and turn west? If you are facing west, how many right angles do you make if you start facing west and turn to west?
Ma'am, 4.
4. Okay, that means you're completing the circle.
Yes, ma'am.
Okay, where will the hour hand of a clock stop if it starts? Say this one, B part. Where will the hour hand of a clock stop if it starts from 8, turns through 2 right angles? 2 right angles, starting from 8, turning 2 right angles.
Ma'am, 2.
2, okay? So that's 2. Then in this chapter, we studied about different types of triangles. Okay, so triangles were like uh, those triangles which have all their measures different, all sides are different. What do we call that type of triangle?
Scalene triangle.
Scalene triangle. And the triangle, what is isosceles triangle?
Ma'am, 2 sides are equal.
Very nice. So on the, we classify triangles on the basis of their sides also and on the basis of their angles also. This is what you have studied, no? So
Yes, ma'am.
on the basis of the sides of a triangle, when we say that all sides are different measure, we call that type of triangle a scalene triangle. When we have two sides of equal length, we call them as isosceles. Okay? And
Yes.
if we have all three sides are equal, then what do we call?
Equilateral triangle.
Equilateral triangle. So this was on the basis of their classification on the basis of their sides. Similarly, on the basis of their angles. How do we represent that? Suppose if we have an angle, we have a triangle where one angle is right angle. What do we call this type of triangle?
Right angle triangle.
Right angled triangle. Okay, so this is called right angled triangle. Okay, and suppose if we have one angle as obtuse angle in a triangle, then what do we call this as?
Obtuse angle triangle.
Very nice. We call it as obtuse angled triangle. And if we have all the three angles in a triangle as acute angles, then what do we name it as?
Acute angle triangle.
Very nice. We call it acute angled triangle, right? Good, beta.
Yes.
Okay. Then furthermore, we studied about Okay, acute angle, triangles. We studied about how do you make angles. Okay, you
Yes, ma'am.
studied that also, no? How to measure, how to make 60-degree angle with using protector.
Yes, ma'am.
If I tell you now, if you have do you have a protector in your hand? Show me, make an angle of 40-degree in your notebook. Then make an angle of 90-degree. Then make an angle of 120 degrees. Please make these three angles in your notebook using protector. Using protector. 40, 90 and 120. Then in this chapter, we had studied about polygons also. Okay. Quadrilateral. We studied some properties of quadrilateral, parallelogram, trapezium. Yes.
Ma'am, actually, I don't have a protractor.
Okay. Never mind, beta. You can do it afterwards.
Yes, ma'am.
Okay. So further, I'm just discussing what else we did in this chapter.
Yes,
We
ma'am.
studied about solid shapes and we studied about the properties of some polygons, right? Polygons like we studied about quadrilaterals mainly. Triangles we studied and then we studied about quadrilaterals. Quadrilateral means those figures which have which are
Four
four-sided
sides.
figures. Okay, so quadrilateral. We studied about square, properties of square, rectangle, parallelogram, trapezium, rhombus,
Ma'am,
right?
so triangle isn't quadrilateral.
No, triangle is a triangle only.
Okay.
Triangle is made of three sides.
Yes,
Quadrilateral is such a figure which is made of four sides. Okay, number of sides in a quadrilateral is four.
ma'am, can it be of more than four sides? Quadrilateral?
See, these are all polygons. What are polygons? Polygons are those shapes which are made with line segment.
Yes,
Okay,
ma'am.
they are not curved shapes. They are not any curvy shape like this. They are made with line segment. I have to make this line segment, this, then only I will get some polygon. Okay.
Yes, ma'am.
Any polygon with three sides, any closed polygon with three sides is called triangle. Okay.
Yes, ma'am.
And any polygon with four sides is called a quadrilateral. Quad means four. Quad means four. Lateral means sides.
Sorry.
Okay. Quad means four, lateral means side. So any four-sided figure is called quadrilateral. Okay.
Yes, ma'am.
And same way, five-sided figure is called pentagon. Six-sided figure is called hexagon. And they are all actually polygons. Okay.
Okay, ma'am.
Triangle is not a quadrilateral. Quadrilateral is something which is made by four sides, like you have square. Okay.
Yes, ma'am.
You have rectangle also. Square has four sides. Rectangle also has four sides. Then
Yes,
you have a parallelogram with four sides. Yes.
yes, ma'am.
Then you have a rhombus with four sides. Then you have a trapezium with four sides. Right? So these are the quadrilaterals which have four sides. And
Yes,
one by one, we studied about their properties also. That in square, all sides are equal and their diagonals are also equal. You understand, no? What are diagonals?
yes,
One
ma'am.
diagonal and two diagonals. And the diagonals are also equal. Rectangles or the opposite sides are equal. equal. Okay, this pair of this side is equal to this side, and this side is equal to this side.
Yes,
Sides
ma'am.
are equal, diagonals are equal. Okay, now suppose if I tell you, beta, that how do you find the diagonals in a polygon? How many, that suppose if I tell you this is a square, how many diagonals a square has? So you can just draw quickly, you will draw from one corner to another corner like this. But if I tell you how many diagonals you have in a pentagon or hexagon, then how will you make? How will you find hexagon, heptagon, or any kind of further polygons? Then
Ma'am,
how
I'll just join all the corners with all.
for that we have to find the number of polygons. We always use to find the number of diagonals in a polygon. This is number of diagonals in a polygon. We always use the formula n into n minus 3 by 2. Okay, where n is what? Sides. Number of sides. So suppose if in a pentagon you have 5 sides, so that means your n is 5 in this case.
Yes, ma'am.
Yes. So in this formula, you will keep your value of n here, n into n minus 5. So that means 5 minus 3 by 2. So that will give you 5 into 5 minus 3 is 2. So that means 5 into 2 is 10 by 2, which is equal to 10 by 2, yani ki 5 sides. So that means in a pentagon, the number of diagonals are 5. Okay. Similarly, if I tell you to find number of diagonals in a hexagon, hexagon is a 6-sided figure like this. Okay.
Yes,
So,
ma'am.
in formula, how will you find the number of diagonals in a parallelogram? In a hexagon, n into n minus 3 by 2. So here in this case, n is what? Number of sides?
6.
6. So you will write here 6 into 6 minus 3 by 2, which is equal to 6 into 6 minus 3 is 3.
Yes, ma'am.
So 6 into 3 is 18 by 2, which is equal to 9. So how many diagonals are there in this? 9.
9.
Okay. So same, if you know the number of sides of the polygon, you can find the number of diagonals in that polygon. Okay. Okay, Neha?
Yes,
Hello?
ma'am.
Okay. So Neha, just revise this. The class time is over now. We had
Yes.
studied about solid shapes also. We studied about pyramids. We studied about size, edges, and vertices of solid shapes,
Yes.
right? A cube, cuboid, pyramid, and all that. Okay, so please revise it nicely.
Yes, ma'am.
Okay, beta.
Thank you, ma'am. Have a nice day.
Thank you. Bye-bye.